finalize the lecture on spatial senses. So the next sensory organ we're going to discuss is the ear, and the ear has three parts. So it receives the sound and transmits. Okay, then you have the middle ear that transmits from external ear to the inner ear, and that's the internal ear there. So this the external ear receive and transmits to the middle ear. This is the middle ear, and from the middle ear you get to the inner ear. So the external and the middle ear usually transmit sound, while the inner ear is mainly for hearing and equilibrium. So that's where the receptors for hearing and equilibrium are located. So we have a tympanic membrane that separates external ear from the middle ear. You can appreciate it here. That's the eardrum. Okay. Then the external ear is the pinna. Okay, and it's able to collect sound, and it has various parts. You have the scaphoid, the helix, antihelix, antitragus. So you need to pause and learn the parts of the external ear. Then we have ceruminous glands that produce wax, and we also have elastic cartilage in this pinna. So the pinna is elastic, it's able to stretch because of the presence of elastic cartilage that's covered by skin. What's the arterial blood supply of the pinna? You have posterior auricular and superficial temporal arteries, which come from external carotid artery. And then the pinna is innervated by greater auricular and auriculotemporal nerves. What is the lymphatic drainage of the external ear? So we have the parotid lymph nodes, the mastoid, which are anterior to the ear. Then you have the mastoid lymph nodes on the mastoid. As you come downwards, you have the deep cervical nodes and the super drainage of the external ear. Parotid lymph nodes anterior to the pinna, then mastoid lymph nodes there, and this deep cervical lymph nodes. External acoustic meatus usually conducts sound, okay, to the tympanic membrane. So it's just a canal. It has two parts. The lateral third is cartilaginous, and it has skin which contains ceruminous glands that produce wax and sebaceous glands. Then the medial 2/3 of the external acoustic meatus is bony. So lateral third is cartilaginous, medial 2/3 is bony. The tympanic membrane of the eardrum is 1 centimeter in diameter. It's thin, oval, and it's usually semi-transparent. So it's able to move in response to vibrations of the air. What's the innervation of the external acoustic meatus? The external surface is by auriculotemporal nerve, while the internal surface is innervated by branches of glossopharyngeal nerve. So the outer ear has the pinna, then that's the external auditory meatus, and then the middle ear begins from the tympanic membrane before you get to the inner ear. So the outer ear is made up of pinna and external auditory meatus. The middle ear has the tympanic membrane. From the tympanic membrane, it contains the ear, the auditory ossicles, the malleus, incus, and steps, the middle ear cavity, and the eustachian tube that connects it to the pharynx. Then you have the inner ear that contains oval window, round window, the cochlea, and the semicircular canal. So the cochlea is the receptor for hearing, and the semicircular canal is for balance. So the middle ear has tympanic cavity, and this is air-filled chamber in the petrous temporal bone. So the tympanic cavity is air-filled chamber in the petrous temporal bone, and that tympanic cavity is actually the middle ear. So the cavity has two parts. There's the tympanic cavity proper, which is in, and we have the epitympanic recess. This is superior to the membrane. So this tympanic cavity is able to communicate with the nasopharynx via the pharyngotympanic tube, and it also communicates with the mastoid cells via the mastoid antrum. So when you have infection in the mastoid antrum, it can get to then the contents of the middle ear. You have the auditory ossicles, so malleus, incus, and steps. Then you have some muscles, stapedius muscle and the tensor tympani muscle. You have nerves in the middle ear, the cauda tympani nerve, which is a branch of facial, and you also have the tympanic plexus of nerves. So you can ask the cavity has two parts, tympanic cavity proper inferior to the membrane and epitympanic recess superior to the tympanic membrane. The communications of the middle ear with the nasopharynx and with the mastoid cells. So this just shows you the contents of the middle ear. Look at the ossicles here. This is the tympanic membrane. So middle ear, this is external ear. Tympanic membrane is what separates middle from external. So the first ossicle that you see here is the malleus. Okay, then that's the incus and that's the steps. And then this is the tensor tympani muscle and this is the stapedius muscle. Cauda tympani of facial is there. Okay, and then you can appreciate the this is the tympanic cavity, and this the auditory tube. So basically, these are the features. The inner ear, we call it the labyrinth. So it has two parts, the bony labyrinth and the membranous labyrinth. Bony labyrinth is filled with perilymph. Perilymph is just a fluid that's similar to CSF. So bony labyrinth has three regions. There's a vestibule, semicircular canal, and the cochlea. Bony labyrinth has three parts, vestibule, semicircular canal, and the cochlea. Then we have the membranous labyrinth that is filled with endolymph. Bony labyrinth was filled with perilymph. So the vestibule, okay? So we're discussing the bony labyrinth. So now the vestibule is the cavity of the bony labyrinth. So you can see here, the cavity of the bony labyrinth is the vestibule, and the lateral wall of the vestibule is actually the oval window. And the vestibule has two membranous labyrinth. We have saccule and the utricle. So this is the saccule here, and this is the utricle. So within the vestibule, we have saccule and utricle, and these sacs, they house the receptors for equilibrium, and these receptors for equilibrium are called maculae. So maculae are receptors of equilibrium that are housed within the saccule and the utricle contained in the vestibule. And these maculae respond to gravity and also respond to changes in the position of the head. In the inner ear, we also have the semicircular canals. So we have three, they're oriented in three ways. So we have anterior orientation, so anterior semicircular canal, posterior semicircular canal, and the lateral semicircular canal. So this is the anterior, this is the lateral, and this is the posterior semicircular canal. Now, these semicircular canals also contain equilibrium receptors. Remember, we had this in the vestibule, in the utricle and saccule, they contain maculae. We also have equilibrium receptors in the semicircular canal, and these receptors are called crista ampullaris. So the semicircular canals have dilated portions called ampulla. Okay, so they have like this portion, the ampulla. So it's at the ampulla that you have these receptors for equilibrium called crista ampullaris. Okay, the receptors in the utricle and saccule were called macula. Receptors of semicircular canals are called crista ampullaris, and they're able to respond to angular or rotational movements of the head. Then, so those are for balance. So balance, we have utricle and saccule with the macula as a receptor, and semicircular canal with crista ampullaris. Then we have inner ear also contains cochlea, and this cochlea is spiral or conical in shape, and it has a cochlear duct which is inside the cochlea. A duct is what houses the receptor for hearing, and the receptor for hearing is called the organ of Corti. Okay, so the organ of Corti is housed in the cochlear duct within the cochlea, and this is the cochlear duct. Okay, so the cochlea usually is divided into three chambers by the cochlear duct. The cochlea is a spiral thing, so it's divided into three chambers by the cochlear duct. So the cochlear duct is actually the inner part. So if you're to look at this cochlea here is divided into three. So this duct is the inner or the central portion. So we have the scala vestibuli. This is the scala vestibuli. It contains the perilymph. Then the scala media, which is the cochlear duct, and the scala tympani, which is the lower portion. Scala media contains endolymph, while scala vestibuli contains perilymph, and scala tympani contains perilymph. Okay, so what is cochlear? Cochlear duct is in the scala media, and so the ear generally is able to help with hearing and balance. So balance is by critical. You perceive sound vibrations, and the receptor are the organ of Corti. So we have mechanoreceptors are what will help to hearing. This occurs at the cochlear duct where you have the spiral organ of Corti. So the sound waves will come to the eardrum, vibrate the ossicles, the oval window vibrates, then it sets the fluid in motion. So the fluid will cause the vibration of the basilar membrane. This is the basilar membrane, it will vibrate, and then these hairs of the organ of Corti will now vibrate and cause an impulse that will be transmitted in the cochlear nerve. So this is the cochlear nerve. So the organ of Corti is made up of these hair cells. You can see the hair cells are the receptors for hearing. these hair cells are the receptors for hearing. So you're bringing in from the ear to the eardrum, it vibrates this basilar membrane where the hair cells are resting. So the hair cells will now vibrate, and that will be sent, they're the receptors, and they will pass that information to the cochlea, and that will be perceived as hearing. So while in equilibrium, when you respond to head movements, then the equilibrium receptors, either the maculae or the crista ampularis in the semicircular canals, will send the impulse, and that will be interpreted as balance. So you have static equilibrium and dynamic equilibrium. So static equilibrium is where now the maculae within the utricle and saccule respond. So the macula will detect the change in the head position with respect to gravity, and then they're also responsible for sense of up and down or head erect movement. So when you tilt your head up and down, okay, so with respect to gravity, the hair cells within the utricle, in the maculae of the utricle and saccule, will detect the movement of the fluid, okay, in them, and that will be perceived as an impulse. Then in the dynamic equilibrium, that's where the semicircular canals come in. So dynamic responds to angular and rotatory movement, while static equilibrium responds to change in head position with respect to gravity. So the semicircular canals are oriented in three planes: anterior, posterior, and the lateral, and they have a dilated portion, the ampulla containing the receptors, which are the crista ampularis. So when you angulate or rotate, rotatory movement, you're able to cause the fluid to move, and these hair cells of these receptors will detect that, and that will be transmitted by the vestibular part of the vestibulocochlear nerve. Thank you very much.